Hi, everybody. Welcome to section 2.2, solving one-step equations. We're going to add, subtract, multiply, or divide. You've only got one step to solve an equation or find the value of the variable. So your end answer for solving an equation is always something like x equals -1 or d equals 7 or something like that. So we're always going to be able to give ourselves a final answer. Our goal, I use these terms a lot, are to isolate or solve for the variable. So if I gave you an equation like x minus 7 equals 3, we're going to solve for x, or we're going to isolate the x so that everything else is on the other side of the equation. You probably know the answer to that, right? X minus 7 equals 3. Well, we know either by using inverse operations or just by common sense that x must be 10. So the value of x is 10. So we've got some inverse operations. I got a lot of stuff here. Addition property of equality means that you can add to both sides of an equation. That's it. So if you add, like we just did, x minus 7 equals 10, that's different than the problem, but we can add 7 as long as we add to both sides. Some people like to put a little line down the equal sign, so you remember if you add 7 on the left-hand side of that line, you add 7 on the right-hand side of that line. Subtraction says that you can subtract from both sides of the equation. So in other words, if I have, let's use a different variable, if I have a plus 9 equals 2, in order to solve for a or to isolate the a, I would subtract 9. Notice I'm going to subtract 9 on both sides of that equation. That's the only way to keep it equal. It's the subtraction property of equality. If I give you 9 pieces of candy and then I take them back, you land with what you started with. So we can finish solving that equation. Multiplication property of equality says you can multiply both sides of an equation. It will still be equal. So maybe we have a b over 6 equals -2. So in order to isolate the b, we have to times both sides by 6. Once we do that, we know the value of b. A lot of these one-step equations, you guys just common sense your way through. And last but not least, the division property. You can divide both sides of an equation by the same number. So if I've got something like 9k equals -27, in order to solve that, we would divide by 9. Now here's the one thing that I didn't mention. We're using this with inverse operations. So that last example that I just did, 9k equals -27, if I want to isolate the k, that means the 9 and the k are getting multiplied. So that's why I want to do the inverse operation. The opposite of multiplying is dividing both sides. Same with the b over 6 equals -2. b over 6, over means division. So the inverse operation, or to undo multiplying or dividing, you multiply both sides by whatever that denominator number is. So we're using inverse operations. This shouldn't be new information to you. You should have done these guys before. Everybody's done one-step equations. I'm going to ask you in class as well. So now we come into, like I mentioned last time, if I give you words, write it as a mathematical equation and solve it. So let's do C, because I know that you can write these. So C, 12 is 1/5 of a number. Find the number. I'm going to do the same thing that we did in section 2.1. I'm going to identify that where that equal sign needs to be. Is means equals. So I've got 12 on the left-hand side. How would you do 1/5 of a number? 1/5 times x or k or d or whatever variable you want to use. But now we're not stopping here. We're actually going to solve. So if I've got 12 equals 1/5 x, I wanted to do this one because first of all, it's got a fraction, and second of all, it's flipped around from how we're accustomed to seeing it. Usually people like the x on the left and the number on the right. We're allowed to switch that order, by the way. That's the symmetric property where we can flip-flop an equation. But just so that you see it is the same thing, we're isolating the x. So my variable is x, that's what I want to get rid of. I've got a 1/5 on the same side of the equation with it, which means I've got to get rid of it. Anytime you've got a number with a variable, remember it means multiply. So technically, what we're going to do on both sides is divide by 1/5. You end up with a pretty large number, but a lot of you hopefully are going to see the reciprocal, the multiplicative inverse. Instead of, and if you like that way, keep it that way. But I'm always, whenever I've got a fraction times my variable, I'm always going to multiply by the reciprocal or the multiplicative inverse. What's the reciprocal of 1/5? 5/1. If I multiply by 5/1 on the right, I have to do so on the left. Notice multiplicative inverse means we'd have 5/5, which is the same as 1, and all we need to bring down, whoops, is that x. So when you multiply by the reciprocal, you end up crossing out, canceling, dividing out, whichever way you see it, those numbers. You're left with just your variable. Your calculator actually is doing that math problem. It is when you divide by a fraction, you multiply by the reciprocal, so our answer ends up being 60. If you're going to stick to the dividing way, please put in the number that was given first and the divided by the fraction second, because test it out on your calculator. 1/5 divided by 12, this is not the same thing. You'll get some kind of crazy decimal. This one is the correct way to do it. But if you just multiply by the reciprocal, you don't even have to worry. All right, so solving equations. Number one, you can see what we need to do, right? M minus 48 equals 29. How do I isolate the M? I add 48. And then I can solve that. I'm not even going to finish solving a lot of these problems because I feel like you know what to do. I should talk about problem numbers 3 and 5. Problem number 3, notice my variable t over 30 equals 7/10. Well, my t is over 30, so if I want to get the t by itself, I'm not even going to worry about the 7/10. I'm going to know that I need to get rid of that 30 to isolate the t. How do I get rid of, what's the inverse operation for over or division? Multiply by 30. Those guys cancel out, and I'm left with whatever that mathematical statement is, which I think is going to be 21. Check the math. Make sure you know how to do that on your calculator. Last but not least, number 5. I've got a negative m over 3 equals 9. Well, whenever I've got a negative, I can put the negative with the m, with the 3, or out in front. So if I stick the negative down here, I still have a negative fraction, right? But now, notice if I've got m over 3 equals 9 and I want to isolate my m, solve for m, I'm going to times by that denominator, which happens to be a negative 3. And now I'm left with a final answer, negative 27. If I forgot and just times by 3, the 3's would cross out, but I would still have that negative left. So then I'd have to take care of the negative later. So if I put that negative in the denominator with a 3, now I can just make sure that my 3 is negative when I multiply on both sides. Right? We've got some more. Didn't we already do those, guys? I think we did. So, your lesson summary. What is it called when you undo an operation by doing the opposite operation? Just a simple one-word, two-word answer. And your practice problem, write the equation and solve it. A number increased by 5 is the same as 42. Find the number. So I want to see both the equation and the solution. And use your stuff from this lesson to do that. All right, that's the end of section 2.2. Hopefully this was all a review for you as well with one-step equations. We'll move on to more step equations after this. Have a great day. We'll see you guys next time.